This is level 2 video lesson number 2. This is from the book chapter 2 section 2 where we are studying conditionals, converses, and their biconditionals. There will be 2 lessons on chapter 2 section 2. This portion is just going to focus on conditionals, converses, and biconditionals. So, a conditional statement, if-then statement that we studied in our previous lesson. Here we have, if an angle measures 90 degrees, then it is a right angle. What's important about the start of this lesson for biconditionals is that we have a true conditional statement. If an angle measures 90 degrees, we have to start with that. Is it true that that means it measures that it is a right angle? Yes, true. Then we look at the converse, which we had from the previous lesson, where we flip it around. If an angle is a right angle, then it measures 90 degrees. Well, this too is true. If someone tells you it's a right angle, you can make the conclusion it measures 90 degrees. When a conditional statement and the converse are both true, this creates a biconditional. A biconditional is a time where it doesn't matter which condition comes first, the conclusion is always true. Now, how will we write a biconditional? If a conditional statement and the converse are true, you can rewrite it in if-then form. If and only if form. We're going to replace the then with if and only if. There will be no if at the beginning of the problem. They're both in the middle. Let's take a look at what this looks like. An angle measures 90 degrees. Notice no if. An angle measures 90 degrees if and only if it is a right angle. Now this can be said the other way. An angle is a right angle if and only if it measures 90 degrees. It doesn't matter which condition you choose to write first because it's a biconditional. An angle measures 90 degrees if and only if it is a right angle is the same thing as an angle is a right angle if and only if it measures 90 degrees. The if is removed, the then is replaced with if and only if. This is how we write biconditionals that only occur when the conditional statement and the converse are both true. With the 2 ifs, we established that either can be the condition resulting as the other is the conclusion. Doesn't matter what comes first. Okay, now, one thing we have to remember though is not all conditional statements that are true have a converse that is true. So just because we have a true conditional statement doesn't mean a biconditional magically happens. If a car's battery is dead, then the car will not start. Well, this is true. It requires the battery in order to start. So, if a car's battery is dead, car's not starting. But let's look at the converse. If a car battery will not start, no, not battery, scratch that. If a car will not start, then the car battery is dead. Is this true? Do we have a biconditional? False. The car could be out of gas. Just because the car won't start, we can't make this conclusion that the car battery is dead. This is not a true conditional statement. The conditional is true, the converse conditional is false. Therefore, there is no biconditional. Our major assignment off of this lesson is to take statements and write them as if-then statements, write the converse, and then decide, is it a biconditional or does it have a counterexample? Let's look at one last example. Conditional. If 2 coplanar lines do not intersect, then they are parallel. Okay, the condition. They have to be coplanar and they don't intersect. these have to be parallel lines. The word coplanar is the most important word here though, because this statement would be false if it just said if two lines do not intersect, then they are parallel, because skew lines don't intersect. But skew lines are not coplanar. So this is a true statement. Now, if we take the converse, if two lines are parallel, then they are coplanar lines that do not intersect. Now, this statement is important because coplanar is not as critical here. If two lines are parallel, then they don't intersect would be true. But then the converse of this without coplanar would be this without coplanar. A really interesting statement that you might want to write down. The converse of the converse is the original statement. Now, this is true. If two lines are parallel, then they are coplanar lines that do not intersect. So we can write this as a biconditional. But in the biconditional, the word coplanar has to be in it. Two lines are parallel if and only if they are coplanar lines that do not intersect. It would not be true if we said two lines are parallel if and only if they do not intersect, because skew lines could be our counterexample to the original. We must be very precise about what we write so that there is not a counterexample that can be used against it. True, true. Two lines are parallel if and only if they are coplanar lines that do not intersect. We could also write this as two coplanar lines do not intersect if and only if they are parallel. Two coplanar lines do not intersect if and only if they are parallel. Critical that things are said correctly and precisely. That's the end of Level 2, video lesson number 2. Good luck on the worksheet.